going to talk about the different types of functions we're going to be running across. And we're also going to go over their basic properties. We're going to go over, let's see, we're going to go over their domain, which is the possible x values that give us real answers. We're going to go over the range, which is the y values that result from this set of x's. So possible y's that result. Go over whether it's an increasing or decreasing and on what intervals. And we're also going to go over whether it's even or odd. And even and odd functions, it's basically just a fancy way of saying symmetrical to the x-axis, or symmetrical to the y-axis, or symmetrical to the origin. Even is symmetric with the y, and odd is symmetric with the origin. And it can also be neither. I forgot to mention that. We can also have functions that are neither symmetric with the x-axis, or with the y-axis, or the origin. And usually the ones that are neither are symmetric with the x-axis, and the reason that we don't have functions that are symmetric with the x-axis is because if we had some function, let's say something like this, then we'd have, you remember our vertical line test, we would have two y's for one x, so that means we're not going to have stuff that's symmetrical with the x-axis. So let's start with the constant function. We'll go in order. And that goes f of x is equal to a constant value, or y is equal to some constant. Like y is equal to 2, y is equal to 3, y is equal to 4. That sort of thing. And the graph of that, depending on where it is, looks like this. Let's just say this was the constant. It can be a negative constant too. It can be down here. It can be down here. But let's just say it's right there for now. So we want to know the domain, the range, whether it's increasing or decreasing, and whether it's even or odd. So let's look at the domain first. The domain, again, are all the x's that will give us real numbers. So we can't divide by 0, and we can't get a negative under an even radical. So here, y is equal to c, or f of x is equal to c. There's no way we can possibly get that. We can put in any x, and it will give us just some constant, and that will be a real answer. So our domain is negative infinity to positive infinity, all x's. And our range is just whatever the constant is. The range for the function, if I put in x is equal to 1, it's going to be that constant. If I put in 2, it's going to be that constant. 3, it's going to be that constant. So the range in this case is just whatever the constant is. Because there's nothing changing this function. There's no x plus 2 or 3 or anything like that. It's just the constant, that's it. So say we had y is equal to 4. No matter what x we put in, it's better to put f of x. F of x is equal to 4. So if we had f of x is equal to 4, no matter what x we put in, it's just going to equal 4. There's nothing else we can do. Increasing or decreasing. Well, if we have a horizontal line, it doesn't change. So it's not increasing or decreasing. So we can just say it's constant. Even or odd. Even functions are symmetric with the y-axis, and odd functions are symmetric with the origin. Here we can see that if we divide down the middle here in the y-axis, it'll be symmetrical. So if I put a mirror here, it's going to reflect this over here. So this is an even function. Next, we have our identity function. Which goes f of x is equal to x, or y is equal to x. And that looks like a straight line. It's like that. So let's look at the domain. What x's are going to give us a real number? All of them. Any x will work, and we can kind of tell by the graph that this would keep going forever, this would keep going forever, eventually every x would have some y. So negative infinity, positive infinity. And same for the range. There's no y value that's going to be excluded from this function. This graph is eventually going to hit every y value on this graph. It's also minus infinity to infinity. So we can't think of any y value that we can't get from this function at some point or another. And now whether it's increasing or decreasing. Now what I like to do for increasing and decreasing is we read it from left to right. I mean, we can think about it as whether the slope is positive or negative, but I tend to... That's another way to think of increasing or decreasing. If m is positive, it's increasing. If the slope is negative, then it's decreasing. Or if we have a graph here, I just like to read it from left to right. I can say, well, the y value is increasing as I go up here, and it continues increasing the entire way through. So this is increasing forever. It starts at negative infinity, and I read it from left to right, and it's increasing. So this is increasing from negative infinity to infinity. Even or odd. You can see that it's not symmetric with the y-axis, but it is symmetric with the origin. Oh, that's kind of bad, but yeah, you can see that if I cut it in half here and I put a mirror there, this would be reflected over to here. So this is an odd function. Next we'll do, alright, let's just go in order, I guess, in a logical order. We'll do the squaring function. F of x is equal to x squared, or y is equal to x squared. And the graph looks like this. Alright, so the domain. What x's are going to give us a real answer? Look here, all of them. There's nothing that is going to give us an undefined answer or a non-real answer. It's negative infinity to positive infinity. And the range here is a little bit different from the other ones. Here, we can put in any x, but we cannot get any y. Because if we put in a negative x, we're going to get a positive y. As we can see in our graph, put in minus 1 squared is 1. So there's no way that we can get any negative y answers. But we can get a 0. If we put a 0, we can put a 0 in, 0 squared is 0. So we're going to start at 0 and then go to infinity. And none of these negative y's are included because we can't get one from this function. So now increasing, decreasing. Again, I like to start over here, read from left to right. So here, our y values are decreasing. Our y values are going down right up until we get to 0. Then from 0 to from 0 to infinity, our y values start going up again. So this is decreasing from negative infinity to 0. But 0 is not included. It's a little bit difficult for me. I can't really prove it to you that much right now without teaching you calculus. But you might be able to see intuitively that as soon as it hits 0, it's neither increasing or decreasing. Remember, if we have a slope, a horizontal line is the slope of 0. That's why I'm saying it might be a little bit difficult for me to explain it to you because you don't know about tangent lines yet. But as soon as we get to 0, the rate of change is 0. It's not increasing or decreasing. It's flat. It's like this. And then once we start increasing, the rate of change starts increasing, so the slope starts increasing like this. See, this is where the slope is decreasing. So if we took the slope, it'd be decreasing, decreasing until we got there. So 0, just know that when you have a place where it changes from increasing, alright, think about it this way. If we ever have a place that changes from decreasing to increasing, then that exact point where it changes, there is no slope. The slope is 0. So 0 is not included because it's not decreasing there and it's not increasing there. It's constant. And it's increasing from 0 to infinity. I hope that didn't confuse anyone, but I can't really think of any other way of explaining it without teaching you calculus, essentially. So even or odd, we can divide it down the middle here and see that it's symmetrical. If I put a mirror right here, it will reflect this over here. So this is an even function. Next we'll do we'll just do the cubing function. So that's f of x is equal to x cubed, or y is equal to x cubed. And the graph looks like this. So, let's talk about the domain. And you're going to see that it looks very much like the x squared function, except for this half is pointing downwards. So the domain, what numbers, oh, I forgot my A, domain, domain. Anyways, what numbers are going to give us real numbers? All of them. There's nothing that's going to give us a 0 or a negative radical. So we've got negative infinity to positive infinity. But unlike our squaring function, we can have negative y values because a minus times a minus times a minus is still a minus. So we can have the possibilities of having negative answers. So we have negative infinity to positive infinity. And we can see on the graph, this goes to, we have negative y values. And this is going to keep going to negative infinity. So we're going to have all negative y values and all positive y values. Increasing, decreasing. Again, read it like a book. Our y's are increasing from negative infinity to 0, and from 0 to infinity. It just keeps increasing forever. It's never not increasing. So we say it's increasing from negative infinity to positive infinity. Even odd. Even odd, well, we can see that it's not symmetric with the y-axis, but it is symmetric with the origin. So this is an odd function. And actually, there's one more thing I should mention before I move on, and that is that this cube function has the same properties as x to the 5th, x to the 7th, x to the 9th, etc. They all look like this, except x to the 5th is increasing faster than x to the 3rd, x to the 7th is increasing faster than x to the 5th, and so on and so on. It just makes the graph a little bit steeper. So this would be like x to the 5th, like this would be like x to the 5th. And this would be x to the 9th. It'd just be even faster. And the same thing with this cubing function. The cubing function, it has all the same properties, same domain, same range, same increasing and decreasing, same even odd as x to the 4th, x to the 6th, x to the 8th, They all look the same, except they'll be a little bit faster. The numbers just get there quicker, but it's the same thing. So I thought I'd mention that before we moved on. So now we'll talk about the absolute value function. Absolute value. And you're going to notice that it has very similar properties to the cubing function. Because if you think about it, it's almost doing the same thing. It's just not multiplying by itself. It's doing the exact same thing. So let's say f of x is equal to the absolute value of x. Y is equal to the absolute value of x. In the cubing function, you have the number multiplying by itself, which cancels out the negatives. But here, the only difference is you're not multiplying the number by itself. You're just taking the integer value. So if I put in -1, I just get 1. Rather here, I'd just be multiplying by itself. So the properties are going to be very similar, as we're going to see. So domain, let me just cross this out so no one gets confused, is equal to all real numbers. And like the squaring function, it has a range of only positive y's. Every time we put an integer value that's negative in here, it's going to turn into a positive. So this is going to be from zeros included. So 0 to infinity. Increasing, decreasing. If we read it from left to right, it has the same thing as our squaring function. The y values are getting smaller and smaller and smaller until we get to 0, and then from 0 to infinity, they're increasing. Negative infinity to 0, 0 not being included, and it's decreasing, and then it's increasing from 0 to infinity. Even, odd. And again, the properties are exactly the same as the squaring function. The only difference is it's not being multiplied by itself. It's not increasing exponentially. So we divide down the middle and we can say that it is an even function. Next we'll do the square root. Trying to figure out what color. Alright, there we go. So it looks like this. F of x is equal to the square root of x, or y is equal to the square root of x. So let's consider the domain. So what numbers can we put in are going to give us real answers? And the answer for this is 0 and all positive numbers. If you put in 0, the square root of 0 is 0. If we put in positive numbers, we get a positive square root, it's fine. But if we put in negative numbers, then we're going to get a negative under a radical. So the domain includes 0 and goes to infinity. And likewise, the range, we cannot get a negative answer from a square root because we can't have a negative under a radical. So we're also going to have a range of 0 to infinity. Increasing and decreasing, read it from left to right, we can see that the y value is always increasing. After a while it increases very, very slowly, but it's still increasing. So this is increasing from 0 to infinity. Even, odd. And here's a case where it's not symmetrical with the y-axis, and it's also not symmetrical with the origin. So it's neither. And again, this is going to have the same properties as the 4th root of x, the 6th root, of x. All this is the graph's going to look the same. All of these properties will be exactly the same. Eighth root, all identical, exactly the same. So I hope that clears up any questions related to that. Now we'll do a cube root. How about that? That's one we haven't done yet. It's cube root. And this is going to look like the cube function but turned sideways. And the square root function would look like the square function. The square root function would look like the square function turned sideways if it wasn't for the fact that the negatives were non-real answers, and it would not be a function anymore. So here we've got f of x is equal to the cube root of x, or y is equal to the cube root of x. So let's look at the domain. So what x values can we put in here? All of them. Because even though we get a negative under a radical, it's a cube root. Remember, a minus times a minus times a minus, it can still give us a minus. So it's alright that we have negatives under a cube radical. So the domain is negative infinity to positive infinity. And the range, likewise, is also going to be negative infinity to positive infinity. We can see that this is going to continue increasing very, very slowly, mind you, but still increasing forever and ever. It's increasing, decreasing. We'll start over here. We can see that the y values are increasing. They're increasing, and they stay increasing. So this is increasing from negative infinity to infinity. Even, odd. It's not symmetrical with the y, but it is symmetrical with the origin. So this is an odd function. And again, this is the same properties apply to the x to the fifth root, seventh root, ninth root, etc. All the same. And finally, we're going to do the reciprocal. Find a purple color. I think that's how you spell it. Reciprocal. Yeah. So that's f of x is equal to 1 over x, or y is equal to 1 over x. And the graph looks like this. So let's talk about the domain. So what numbers for x are going to give us a real answer? All of them except for 0, because we cannot have an undefined in the denominator. And you can look at the graph. You can see that the graph, as soon as it starts getting close to 0, it just shoots up. Because it gets, I mean, if you look, if you put smaller and smaller numbers in this, say you put 0.1, it's going to turn into 10. It's just going to keep getting bigger and bigger. If you put in 1/10, then it's going to get 10. If you put 1,000th, that's going to be 1,000. So the smaller and smaller you get, the faster y is going to increase. You can put it into a calculator and see. Because this cannot touch 0. It can get infinitely close. This is what is going to be called an asymptote. And we haven't really talked about them yet, but an asymptote is a place where there is almost like an invisible wall where the graph cannot touch. See, all of the x values except for 0 can go in there, and that includes like 0.0000001. It can get infinitely close to 0, but it cannot touch 0. It gets infinitely and infinitely and infinitely closer to 0, but it will never touch it. So that's why it shoots up like that. So our domain is negative infinity to 0 and 0 to infinity. And the range is exactly the same. The only value that will never result from this is a 0. It's negative infinity to 0, 0 to infinity. Increasing or decreasing, we can look and start over here and say what's happening to our y's. Our y's are decreasing. They're getting closer and closer to negative infinity as we approach 0 from this side. But remember, we cannot touch 0, so this graph is completely separated. This graph does not connect. So we go to negative infinity, and then we have to cross over 0 because this is not going to touch this graph. This is an asymptote. It's an invisible wall. So here we start from a very high y value, and then we come down and we're decreasing and we're decreasing and we're decreasing, and then we keep getting smaller and smaller and smaller. So our function is decreasing from negative infinity to 0, and then from 0 to infinity. But 0 is not included, so it can't be decreasing on it. And then we're going to look at even or odd. And we can see that this is not symmetric with the y-axis, but it is symmetric with the origin. If we put a line like that, so this is an odd function. And these are all the basic functions we're going to be dealing with. I'm going to go over a couple more, like the integer function and piecewise functions, but we're not really going to see those too much at all until, I mean, you see like piecewise, I guess you see the integer one maybe in, was it like, I remember in physics there's some uses for it for turning things on and off, but you're not really going to see them too much. These are the main functions we're going to be dealing with, so become familiar with them, learn how to recognize their graphs, because you're going to be seeing them all the time.